Hello everyone, my name is Hoang-Giang from Computer Game and Intelligence Lab, National Yan Ming Tung University from Taiwan. Today I'm going to share our work, Image-Based Regularization for Action Smoothness in Autonomous Racing Car with Deep Reinforcement Learning. Deep Reinforcement Learning has successfully solved many complex controlling tasks. However, one critical problem of DRL is the jerky problem, where the agent may suddenly change the action due to the dynamic of the environment. Jerky control may cause control inefficiently and dangerously, especially in autonomous racing when the car is moving at high speed and requires a short time response. In this work, we first propose image-based regularization for action smoothness, IROS, in autonomous racing car for dealing with high-dimensional or image-based input. We then introduce impact ratio control, an adaptive regularization weight to flexible constraint. Our work inspired by a work called CAPS, Conditioning for Action Policy Smoothness of My Shore. CAPS is constructed with the temporal smoothness penalize the difference in action between two consecutive states, and the spatial smoothness penalize the difference in action between two similar states. CAPS smooth the control of drone using internal state with low dimensional input. So in this work, we extend to autonomous racing car with high dimensional input or image-based input, which is much more challenging because of the diversity of data. In this work, we're dealing with high dimensional data, where the input is RGB image. We also use two regularization terms. First, spatial smoothness term encourage the model reduce the difference in action between two similar states. We use domain randomization method to generate similar state from the current state. Here we categorize the domain randomization into two types: geometric transformation, where we translate, rotate, or shift the input, and photometric transformation, where we change the value of each pixel of image, like random brightness or adding pepper and sand. For temporal smoothness, we also reduce the difference in action between two consecutive states. We use these two regularization terms with objective function of reinforcement learning to train the agent. However, these two regularization terms strictly constrain the action changing, and is not suitable for racing car, since the car may require rapid adjustment for speed reduction or changing steering angle during curves. To solve this problem, we introduce impact ratio control, IR control, an adaptive regularization weight to flexible the constraint. The IR control allows the agent quickly change the action in case needed. The impact ratio is constructed by combining normalized speed and normalized reward. This table is an example of impact ratio value and possible behaviors. When both speed and reward are high, it means the car is moved on track with a high speed. In this case, we should maintain the current action. While if the speed is low but get high reward, the car may reduce the speed at curve and has correct heading to track the center line. In this case, we need to relax the constraint to allow the agent change the steering to make a turn. And if both speed and rewards are low, which means the car is moving at low speed and wrong heading, in this case, we need to change the current action. We then use the impact ratio to control two regularization terms. In the experiment, we use AWS Deep Racers, a platform support both simulation and real environment for miniature car racing. We can see that the IROS agents significantly improve the smoothness of steering action compared to the vanilla SAC, and IROS with IR control even perform better, with higher success rate and finish the track in a faster time. Here is the demonstration in real world. We can see that the vanilla SAC agent has shaky trajectory. The IROS agent obtains smoother trajectory but still make a big curve at a turn. The IROS agent with IR control performs better at a curve, therefore finish the track faster. With this approach, we won the 2022 AWS Deep Racer Championship.
Another clean start.
It's a strong run. Is it going to be good enough? Coming to the line. Let's check the time. 13.756.